In a lab at Harvard, a pulse of light went into a cloud of atoms and didn't come out. The cloud held it, still. For a full thousandth of a second, the light was simply gone. Then they switched it back on, and it left the cloud intact and kept going. Light is the fastest thing there is, the one speed the universe will not let you break. So how do you stop it? And where does it go when it stops? Start with slowing it down. In 1999, the physicist Lene Hau cooled a cloud of sodium atoms to less than a millionth of a degree above absolute zero. Cold enough that the atoms stopped acting like a gas and started acting like one single thing. That cloud is opaque. Shine light at it and the atoms swallow it whole. So Hau's team added a second laser, a coupling beam, fired straight through the cloud. That second beam rearranges the atoms so they can no longer absorb the first one. The cloud turns clear. And here's the strange part. Making it transparent also makes it thick. The light still passes through, but the cloud drags on it, hard. Hau clocked the pulse crawling at 17 meters per second, slower than a car on the highway, roughly 20 million times slower than light moves through empty space. They hadn't broken the speed limit. They had built a medium thick enough to almost ignore it. But slow is not stopped. The next step was to make it stay. So in 2001, they made it stay. The key was that coupling beam, the one holding the cloud transparent. While a pulse was crawling deep inside the atoms, they switched that beam off, and the pulse stopped. Not faded, stopped. Held inside the cloud, going nowhere, for up to a full millisecond. Then they switched the coupling beam back on, and the pulse woke up and finished its trip out the far side. Hau did this in her ultra-cold sodium, but the same year, a separate team, Ronald Walsworth, Mikhail Lukin, and David Phillips, working just down the road, did it in a warm glass cell of rubidium vapor. No frozen exotic matter at all. An ordinary gas, near room temperature, catching light and letting it go. So it wasn't the strange cold cloud doing the work. Something more general was going on. Which raises a harder question. If the light is sitting still in there, frozen, waiting, then what exactly is holding it? Here is the turn. Nothing is sitting still in there. The light is not parked inside the cloud like a car in a garage. The instant it slows, it stops being purely light. Two physicists, Michael Fleischhauer and Mikhail Lukin, worked out what it actually becomes. A hybrid, part light wave, part pattern stamped across the atoms themselves. As the coupling beam fades, the balance shifts. Less light, more matter. When it stops completely, there is no light left at all. What stays behind is a pattern, the pulse's exact shape and timing, written into the atoms as a wave of aligned spins. The photons are gone. And then, in 2007, Hau's team pushed it further. They stored that pattern in one cloud, let the pattern drift across open space as a slow ripple of matter, about 200 meters an hour, and read it back out as light from a secret cloud, sitting 160 millionths of a meter away. So go back to the start. The light that came out of the cloud, was it the same light that went in? No. The photons that went in were absorbed, erased. What the cloud kept was never the light itself. It kept the information, the shape, the phase, the quantum state of the pulse, copied into matter and held there. When the coupling beam returns, the atoms build a fresh pulse from that blueprint. New photons, an exact copy, walking out as if nothing had happened. And that is the part I can't get comfortable with. We say they switched the light back on because the copy is perfect, and the easier story is that it's still the same beam. But the original was gone the entire time. This is what a quantum memory really is. Not a box that holds light still. A way to write light into matter and read it back without losing the one thing that made it light. It is the piece a quantum internet would be built from. So where does the light go when it stops? Nowhere. It stops being light. For 1,000th of a second, it lives as a pattern in a cloud of atoms. Then it is born again, exact. The open question now, how long can that pattern hold? Long enough to carry a message no one could read? The light never paused. It was copied, and the copy never knew.